Hello guys, welcome to Solving Solutions, your number one channel where I get solutions to all your solving problems. It's nice having you in class again today. How have you been? On today's tutorial, we are going to show you how to use the Euclidean distance in ArcGIS, and then we have written a few stuff here. It's actually the planar 2D flat surface straight line distance from each raster cell to the nearest source feature. Our source feature we are going to use is actually the different road networks that we have within this our project extent. Now, if we come back to our guide, it assumes a Cartesian coordinate, which means your data needs to be in a projected coordinate reference system. So if we right click and then we come to the properties and then we go to the source, you are going to see that the coordinate system is a projected system, and then that's in zone 32, right? Good. So if you're using your own, you should ensure that you reproject if it's in a geographic towards a projected system. Then the next thing is that when it gives you a range, it actually gives you the range based on the distance unit. So now let's come to our ArcGIS. The first thing is that let's search for the tool, which is the Euclidean distance, the Euclidean allocation, and the direction, right? Good. So we need that of the distance. Now it calculates for each cell the Euclidean distance to the closest source. This is for the input, and then if we drop down, the input will be either the highway or the route, right? Good. So let's use the highway for demonstration, and then you now see the output distance raster will be stored in this directory. We are going to leave it that way. Now we are also going to leave these options as default as they are. Now you see the output cell reference to be 30. So let's come back here. Most times before you start, you should set your environment to a defined extent. So let's come to geoprocessing and then environment. So what we did was that since we have a boundary here, which is this Asalga boundary, we came down here to say the processing extent should be as specified below, which is what this Asalga boundary. You can see it. Then we also came down to the raster analysis, and then for the cell size, which represents the resolution, we use the drop down to say as specified below, and then we define 30, which means the output will be what, a 30-meter resolution raster, right? Good. And then we are also maxing it, that means clipping it to the extent of what our boundary or our area of interest boundary, which is Asalga, right? Good. So we clicked on OK. That's why when we came to this Euclidean distance and then we imputed the highway, you saw that the output raster is automatically 30, right? Good. So if we come back to environment again, you would see that the processing extent is fixed, and then if we come down to the raster analysis, you also see that what it is fixed, right? Good. So doing that from the beginning saves you the stress of coming back here to set it. However, if you did not set it here, you can also come back here to set it, right? Good. So we have imputed the parameters we need, so let's click on OK. Good. So we have what? The output raster. Now let's look at the interpretation. Now when you use the road file as the input, the Euclidean distance analysis in GIS, the output raster shows straight line. So the ranges are these, which are just like for an example. These ranges represent distance in the map unit, which in our case is meters. So if we want to analyze it to different zones of proximity for suitability analysis as an example, we can say areas within 0 to 10 of the road are very suitable, from 0 to 100 rather, then from 100 to 300 moderately, and then beyond 300 what, less suitable, right? Good. So now let's come back here. We can see ranges, and then we have been able to identify that these are what distances, right? Good. So we have 0 to 936 meters, 936 to 1800, down to 9 kilometers, right? Good. So what this simply means is that from the road, these raster are having distances to the source, which is the road, right? Good. They have been grouped using this for the purpose of symbology. So if you double click on it and then you come to the symbology, you can see the type of symbology that is used and then the classes and all of that, right? Good. Now we are going to do something. We are going to reclassify this raster so that we know that values ranging from 0 to a particular value will be either suitable or not suitable based on their proximity to the road, right? Good. So we search for another tool called reclassify, right? Good. So we use the spatial analyst, and then the input raster will be the Euclidean distance we have, and then you now see the currently available classes, right? Good. So we want to reduce it to 5, so we click on classify, and then for the method we still leave it as the natural breaks, and then we reduce this to, okay, let's use the drop down to 5, right? Good. Then you now see the different break values. You can also decide to change it if you want, because they represent these lines, right? Good. So if you want to modify it, you can actually do that, and we click on OK. So you now see that the old values we have, new values will be assigned to them based on the criteria we are going to define. So now let's come back here. So you say, what is the essence of reclassifying the distance to a range like 1 to 5? Now in GIS analysis, especially suitability modeling, reclassification is used to simplify, standardize, and assign meaning to raw distance values by grouping them into classes with relative importance or preference. So if we look at it, these are some raw distances, but they are not useful to us until we classify them. Now the classification will now be when it is 0 to 5, that's 500. It's classified as 5 because it's very suitable. You know, from 1 to 5, 5 is the highest, so we are looking at it as 5 to be the most suitable. Then from 501 to 1 kilometer is suitable. 1 kilometer to 200 least suitable, and moderately suitable, down to distances that are 300, that's 3 kilometer away from our source point, which is what, less suitable. That means distance to the road, right? Good. So suitable sites for LPG depots, right? Good. So if they are this far from the road, then they are not suitable sites, because the depot should be very close to the road, right? Good. So there are other criteria that you can actually impute in your suitability analysis model, right? Good. But this is a criterion, and then when you are trying to reclassify it, you now see the relative importance, right? Good. So instead of just working with the raw distance in meters, you are working with a priority score, which you can combine with other reclassified rasters, right? Those are the other criterion or the other criteria that we have in your weighted overlay. That's for your analysis, right? Good. So let's come back to our ArcGIS. So we have this as 5, that's very suitable. We have this as 4, moderately, 3. Then we have this as 2, and then we have this as 1, that's least suitable when they are about 9 kilometers away from the road, right? Good. So now this will now help us to standardize, as we have read here, simplify, standardize, and assign meaning to these our raw distances that are in these ranges, right? Good. So we click on OK. Good. So we have what, our range from 1 to 5, and then we have some values that are actually outside of the range. So let's just leave them out for the demonstration purpose. Now let's come back here. We have reclassified to the scale 1 to 5, and then we are trying to also compare it to buffer. Now, for instance, if we try to say from, okay, let's take out the reclassified, then let's take out the Euclidean distance. So let's say if we have this road, and then we want to know the region within maybe a particular radius or some radii from this road, we can say, okay, 100 meters from the road, 200 meters from the road, as the case may be. And you know, the higher the radii, the farther apart those regions are from the road, right? Good. Now, according to what we have here, buffering gives you simple yes or no results. Region that include all areas within a specific distance from a fissure, 500 meters from the road. Everything inside of the fissure is considered part of the zone. Everything outside is excluded. So it is fixed distance ring. Now when you come to the Euclidean distance, on the other hand, it produces a raster where each cell contains the exact straight line distance to the nearest source, which is our road. So instead of having a single fixed distance, it gives you a full gradient of distances from 0 outwards. You can identify multiple zones, distance like maybe 0 to 500 as the case may be, and then assign different scores which you can use for what, your analysis. So buffer gives you a fixed zone, whereas the Euclidean distance gives you what, a full distance surface, letting you analyze and classify, prioritize location based on how close or far they are from what, a fissure. So you now see that, let's bring back this. You know, okay, let's use this. You now see that we have a surface that's a raster surface, right? Good. That if we try to identify, that select, good. If we use the identify tool and we click on any part of the surface, Okay, so now let's use the drop down to select Euclidean distance, right? Then when we do that, we have selected the right layer we want to identify from. So now if we click on any part, it gives us what? The distance of that particular pixel from the road, right? Good. So you see this is 123, but as we go further, you see it's 900. As we go further, it's 1 kilometer, as the case may be. So this now gives you, as we have said here, a raster where each cell contains the exact straight line to the nearest source, right? Good. So you identify multiple zones or distance bands like we have here, and assign different scores or weight, which you now use for what? Your analysis. So the example we are using here is what? Trying to locate the suitable site for LPG depot in a particular location, right? Good. So basically we have shown you using ArcGIS how you can use the Euclidean distance, how you can reclassify, and then we have also compared it to buffer to know which one is best used when you want to make informed decisions like suitability analysis, site selection, and other related tasks, right? So we have provided solution to this particular GIS problem. If you have any question, comment, you can leave it in the comment section and we'll get back to you as soon as possible. We can also help you fix stuff like this. You can reach out to us via the number displayed on your screen and we'll get back to you as soon as possible. So until we see you on the next tutorial, ensure you keep staying safe and have a fantastic time. Bye.